about absolute value inequalities. Now, the steps to solve an absolute value inequality are almost identical to those solving an absolute value inequation, with just a few small tweaks that we'll go over here in this video. I've included those steps on the right-hand side, steps to solving absolute value equations. Get rid of anything outside of the absolute value. Then you split into two equations. Remember, one of them is positive, one of them is negative. Solve each side is the last step. So let's go ahead and talk our way through solving absolute value inequalities. You'll notice the steps are the exact same, okay? So the first thing we've got to do is get rid of anything outside the absolute value. We're looking at the problem here on the left. You see negative 4x is greater than or equal to 32. We don't have anything outside the absolute value, so that step is already done. Let's go ahead and split into two equations. We end up with negative 4x is bigger than or equal to 32, and negative 4x and 32, which we make negative. Notice, when we make this side negative, we have to flip the sign. That is probably the trickiest part about this. Flip the sign. Flip the sign when we make the one side negative. The reason being, it's the exact same as any other kind of inequality. If you change the sign of the one side, you have to flip the direction. Okay, so let's go ahead and solve each equation. We're going to divide by negative 4, divide by negative 4. We end up with, not n, different letter, x, and negative 8. And notice, since we divided by a negative, we have to flip the sign. Let's go ahead and write that as interval notation. So now we've got numbers smaller than negative 8. So that's going to be negative infinity to negative 8. Always a soft bracket around infinity. We're going to do a hard bracket around the negative 8 because it's included. All right, let's go ahead and solve the other side. We have negative 4x is less than negative 32. Divide by negative 4. Divide by negative 4. We end up with x is less than 8. But what did we do? We divided by a negative, so we have to flip the sign, which gives us 8 to infinity. We have two different, we have disjoint intervals, meaning we have two different things and they don't overlap at all, so we have to include the union in the middle. All right. Let's go ahead and do one more example. Let's do x minus 3, absolute value, divided by 9 is less than 2. Okay, so the first thing we've got to do is get rid of the thing that's outside of the absolute value. In this case, that's a 9. So let's go ahead and multiply both sides by 9, which gives us the absolute value of x minus 3 is less than 18. Now we can go ahead and split into two different equations. X minus 3 is less than 18, and x minus 3 is bigger than negative 18. Notice I flipped the sign because I made that 18 negative. Well, let's go ahead and solve each side. We add 3, which gives us x is less than 21, and we can do the same thing over here. We add 3, which gives us x is bigger than negative 15. Let's pause for a second and think here for just a second. What numbers work here? I've referenced the negative 100, 0, 100 test before. Let's apply it here. Does negative 100 work here? Well, no, it doesn't, because 100 minus 3, absolute value, divided by 9 is going to be 103 over 9, which is definitely not less than 2. A 100 follows to the same thing, but notice 0 does work. 0 minus 3 divided by 9 is definitely less than 2. So our interval has to include 0. Now we'll go back to over here. Notice we have numbers less than 21 but bigger than 15. I mean negative 15. I think there's an overlap there. So I think that means we're going to treat it like an and get a single case of interval notation. It'll look something like that. There's your final answer. If you have more questions, feel free to email me and ask for more clarification.